This is the first video lesson for the atomic theory unit. This is unit number 3 in this course. Today we're going to talk about how can we analyze parts of the atom. So download the new class packet from my website under unit 3. Then go to page 3 in the new class packet. I want you to answer these questions of the motivation so you could then compare it with the information I'm going to tell you in this PowerPoint. Learning target. At the end of the lesson, I'll be able to describe the structure of an atom and the properties of the subatomic particles, protons, electrons, neutrons. For homework, it will be number 1, which will be a junipod based off of this lesson. So this is a recap from the first unit, the first video lesson. All matter is made of tiny particles called atoms. Atoms are the basic building blocks of matter. If you recall, I told you that we cannot see atoms. We're studying something we cannot see, right? So this is the artist's depiction of aluminum atoms. So the question is, how do people figure out the parts of an atom? We will answer these questions in this unit. Here's a cell, here's an atom. A cell is a living thing, but atom is not. Both have a nucleus, but the nucleus is referring to different things. In a cell, a nucleus is an organelle that contains genetic material. In an atom, it is a dense center that contains the protons and the neutrons. Okay, so let's fill in this table for the subatomic particles of an atom. So there's 3 particles, proton, neutron, and electron. What's the charge of a proton? It's positive 1, right? So positive P. Mass of a proton is 1. AMU is the unit of mass here. AMU stands for atomic mass unit. You can look it up on the reference table. The location of a proton is the nucleus. For a neutron is 0, right? Neutral, neutron. Mass is also 1, AMU. The location is also the nucleus. For electron, the charge is negative 1. The mass is 1 over 1836, which is close to 0. The location of the electron is outside the nucleus, that is the orbitals. A nucleon is subatomic particles in the nucleus. So which of these 3 particles are nucleons? That would be the protons and the neutrons. Based on this chart, prove that the charge of the nucleus is positive. So what's in the nucleus are the nucleons, which is protons and neutrons. Since neutrons are neutral and protons are positive, the nucleus can only be positive, right? It's not neutral or negative. It has to be positive because it has protons and it has neutrons only. Okay, so as I stated before, AMU or U is atomic mass unit. Either one is fine, they both stand for atomic mass unit, which is the unit of mass of atoms and subatomic particles. So now let's go to table O in the reference table. So flip there, we're going to look up the symbols of these particles on table O. You do not need to memorize them because they're on the reference table, but you must be able to interpret them. For proton, is this P, neutrons N, and electrons E. So what do you think these numbers stand for? So the bottom number is the charge, right? So neutron is 0, proton is 1, electron is negative 1. And the top stands for the mass. So mass, proton is 1, neutron is 1, and electron is assumed to be 0, because this is a very small number. Learning check number 1. Which statement describes the charge of an electron and the charge of a proton? Pause the video and resume once you have the answer. So if you were paying attention, this should be fairly straightforward. The answer is 4. An electron has a charge of negative 1 and a proton has a charge of positive 1. Which particle has a mass approximately 1 atomic mass unit? So pause the video and resume once you have the answer. So we haven't discussed 1 and 2 yet, so they're obviously wrong. So the best answer is 4. An electron weighs 0, or about 0, so that's wrong. Which part of the helium nucleus is positively charged? Pause the video and try to do this yourself. Okay, so the answer is 3. Electron is negative, a neutron is neutral, A nucleus contains protons, which is positive. An orbital is where the electron is. Which total mass is the smallest? So try to do this yourself, pause the video, and resume once you have the answer. Okay, so the answer is 1. The mass of 2 electrons is about 0, because each one is 0. The mass of 2 neutrons is 2, because each neutron is 1. The mass of 1 electron plus the mass of 1 proton is about 1, right? Because this weighs 0. The mass of 1 neutron plus the mass of 1 electron is about 1. Because neutron weighs 1, electron weighs 0. So the best answer is 1. That's the smallest. 0 is smaller than all of them. So here is an example of a model of the atom. Most of you will probably drew something like this for the motivation. There's actually more than one model of the atom, right? But this is the one I want you to be most familiar with. So here is showing the nucleus, where the protons and neutrons are, and electrons are on the orbital. So check of understanding. What does the orbital ring stand for or mean? So does this ring actually exist in the atom in reality? The answer is no. This is just part of the model. These lines, the circle does not exist in the real atom, okay? It's just lines to show where the electron is. Check of understanding number 2. What happens to the charge of the atom when the number of protons equals the number of electrons? So here we have 3 protons and 3 electrons. What do you think is the charge of the entire atom? So the charge is going to be 0 or neutral. So an atom has a neutral charge, which means the charge is 0 because the number of protons equal the number of electrons. So in general, this is including the regions, atoms are assumed neutral unless stated otherwise, right? So that means atoms have protons equal to electrons, right? They're assumed to be neutral. So here are some examples of models of atoms. So you could draw either one on exams. I recommend this one because if you draw this, if it's a big atom, you gotta draw a lot of circles. And if an atom has a lot of electrons, that's a lot to draw. So this is very simple. So you could draw either this or this on the exam. So now we're gonna do some mass comparisons of subatomic particles just to give you an idea. So we know a neutron and a proton has equal mass. So it's going to be balanced. But if you have a proton and electron, the proton weighs a lot more than an electron. Now we have to compare the strength of the charges. So electron is negatively charged, a proton is positively charged. They have the same strength. Even though the electron is much smaller than the proton, they have equal strength. Right? But opposite charge. Okay? So now we're going to discuss theme number 2. Opposites attract, same charge repel. So this is a very common theme in chemistry or in science in general. So basically opposites charge attracts, same charge repel. So you see the positive and positive repel, negative, negative repel. Well, if it's positive and negative, they attract. So now I want you to watch a TED video. So pause the video, go to the description under this video, and watch the link of the TED video. Resume this video once you watched it. So I'm assuming everybody has watched the video. So here is a very nice diagram showing the relative sizes of things. Right? So these are things you're familiar with. We're here, we're humans, so we're assuming 1 meter here. The atom is about 1 angstrom or 10 to the minus 10 meter. So we are about 10 to the 10th power in terms of size differences. Okay? So this is from the video. So let's imagine that the stadium was an atom. So this red dot over here, that's the nucleus. So that would be a size of a marble or a pea, right? So you can imagine that the atom is mostly empty space with a tiny speck that is actually the nucleus, right? So for summary, atom is the smallest unit of an element. Atoms are made of protons, neutrons, and electrons. Protons and neutrons are in the center, and the electrons are outside the nucleus, all right? So this concludes the video lesson for today. remember to do the Juno Pod homework.